Hey there, Esther. I was just going to go over the problems, and then you can ask questions of the ones you still need more help on. First one, it asks whether it is an enlargement or a reduction. So we call K a scale factor. Here's the basic rule. If K is bigger than 1, it's an enlargement. If K is less than 1, then it's a reduction. So this would be an enlargement, reduction. This 3 goes in there, that's 1 1/3, which is bigger than 1. So of course that is an enlargement. Number 2, which triangle postulate theorem would make the triangle similar? Similar means same shape, different size. Same shape, different size. And there's 3 of them. There's angle, angle, similarity, side, angle, side, similarity, side, 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 similarity. So taking a look here, we see that this is 60 and this is 60. So we at least have a congruent angles. Let's check. 60 and 82 is 142 away from 180. That's going to get us 38. That means if this is 38, this is also 38. So I have 2 congruent angles here, and the similarity therefore is angle, angle, similarity. Said you're going to graph the image using a dilation about the origin with a scale factor of 1/2. So first you would find all the points here. And B is at 4, 5. And A is at -2, +4. Oh, that's not 4, 5, that's 4, 6. 1, 2, 3, 4, yeah. And then C is sitting at 0, -4. So scale factor 1/2 means you're shrinking. So you multiply all of them, 4 and 6, -2 and 4, 0 and -4. You multiply everything by 1/2. Multiply by 1/2, basically divide by 2, and what do you get? Well, this you're going to get 2 and 3. This one times by 1/2, divide by 2, -1, +2, and then of course that's 0, -2. If you were to plot those points, you'll see the exact same image, but about half the size. Not about, but is. There's 2, 3, that's called B prime. And then there's -1, +2. That's called A prime. And then 0, -2. C prime. So same image, just shrunk down. Translation, 5 to the left and 2 down. There's 2 ways to do this. One, you can just physically move stuff. So 5 to the left, 2 down. And there would be your next B, kind of B double prime, if you will, same image. Or, so you could just physically move everything. Or if you had to do this mathematically, you have 4, 6, 5 to the left. Left, right is an horizontal motion, so you'd -5. 2 down is a vertical motion, -2, and you get -1 and +4, which if you look here, -1, +4 is exactly what you get. So you could either physically bunny hop it or take the horizontal motion away from the first and the vertical motion away from the second. coming here. Which similarity postulate? You should have a little similarity sign going on for all of these. Side-side angle is not a similarity postulate, so you can chuck that. Let's see what we have here. Well, 1, we have a right angle. 2, we have an angle in the middle. So we have a pair of angles in the middle. And let's check our sides. We're going right angle to the middle, right angle to the middle. So the 6 goes with the 10, and we reduce that. We know 2 goes in here 3 times. 2 goes in here 5 times. And we come here, 8, there's nothing to match with the 8, and there's nothing to match with the 9, but we already established that they're similar because of the angles in the middle and the right angles. So it would still be angle-angle similarity. We're told that BC and WV are parallel, which means you have a pair of alternate interior angles. I call that armpits of the Z. You also have a pair of vertical angles. So first off, I know these are similar by angle-angle similarity. Once you establish similarity, you do what's called match and mirror. Match and mirror. And I know that from here to here, its match is the 2. It's in the same position. So I'm going to work top to bottom. So I'm going to go x over 2. Then top to bottom, 7 over 3x minus 1. Just for giggles, just so you can see it both ways, I could have done this. Short to long, x over 7. Short to long, 2 over 3x minus 1. Either way, you cross multiply and you solve for x. Here, I know the triangles are similar. I'm going to pull them apart. Whenever you have overlapping parallel lines, it's a good idea to pull them apart. I know they're similar because they share this angle. And because of the parallel lines, these angles are congruent. They're corresponding. So the triangles are similar by angle-angle similarity. This is x, and then over here, that's 12. Excuse me, that's not x there. X is the long one. This is x. And then this is not 12, it's 20, it's 32. So you want to match and mirror. And we know that doesn't work because we don't have anything to match with this side. So you have to ask yourself what else you can do. So we can find a different set of matching. We know x does match with 32. And then we can do this. The 45 matches the 20. What I mean by match, it's in the same position. And you cross multiply. Five goes in there 4 times. 5 goes in there 9 times. 4 goes in there 8 times. 8 times 9, 72. We take a look here, and we have a pair of angles in common. Now we're going to match short side to short side. So 92 to 35, I'm going to reduce that to see what the ratio is. I know 7 goes in here, so divided by 7. We're going to see if 7 goes in there as well. That's going to be 5. 92 divided by 7. Okay, so that doesn't reduce. Let's check here. 143 and 55. I know 11 goes into 55, so that's 11. Let's see if 11 goes into 143. $143, 11, once 33, 13. Okay, so 143 divided by 11 is 13. 55 divided by 11 is 5. So I have 13 over 5. Okay, that doesn't match. So these triangles are not similar. That's why it says if possible. We were seeing if we had side angle side similarity going on here. So let's check and one more ratio here. I know 5 goes in here 7 times. 5 goes in here 11 times. 92 is not divisible by 7, so it doesn't work. So this is a not possible. Which of the following is correct for a similarity statement? Well, I know they're similar by angle, angle. So all you have to do is match short, medium, long. So JKL, JKL. Notice that goes short to medium. MPN, MPN. Notice that goes on the long side there, so that doesn't work. PNM, PNM, medium, short. LJK, LJK. That doesn't work because over here it was medium, short. This one is long, short. So that one doesn't work. So you just keep tracing until they match. JKL, JKL, that's short to medium. MPN, MPN, that's long to short, long to medium. Nope. So now you'll see that obviously this last one, but trace it anyways. LJK, LJK, that's long to short. MPN, MPN, long to short. That works. So taking a look here, it's saying if N is congruent to R, what additional would make them similar? Now, remember, all we need is angle, angle similarity. So that's all we would need would be another pair of angles. So all you have to ask yourself is what would give you another pair of angles. Now, N and R right angles wouldn't work because you already have N and R as congruent. So that doesn't work. NP perpendicular to PR. That doesn't get you another pair of angles. NP parallel to RT. Aha! That gets you another pair of angles because that would get you corresponding angles. And that would get you angle, angle similarity. So this is the one that would work. Describe the composition. Okay, what we have going on is actually two compositions. One, we're reflecting over the It's very obvious we're reflecting over the x-axis. So that's 1. We have dilated. So let's get our actual compositions here. I'm not sure how much detail. Dilation means to shrink. We have dilated. We've reduced. And we've translated, which means we've slid it around. And I know that because if all we did was reflect over the x-axis, this C would be straight down over here somewhere. So I know we have translated, which means we slid it around. So that would be the general. And if you needed the specific numbers, you would have to get each of these coordinates and figure out what is it dilated by, what did you multiply exactly by to shrink it down, and then figure out how we moved it. Obviously, it's a certain number to the right and down. Solve for x if possible. So we are not giving any angles here, so we have to check short to short, long to medium, long to long. So I'm going to start here with short to short, 39, and then 130. You see if I can reduce this at all. I know they're divisible by 3, at least this is. Divisible by 3 would get me 13. Divisible by 3. Oh, there's another way. That's not going to work that way. Let's check this way. We're given 2 angles here. No, the only way to test this is by similarity. So short to short, medium. Oh, notice here you have 2 equal sides. Here you don't have 2 equal sides. So they are not similar. The ratios do not equal. Over here, we're going to check to see if our ratios work. To begin with, solving, oh, we're told they're similar. Good, we don't need to figure it out. We're told they're similar. So all you have to do is match up short to short, long to long. So here, we're going to color code it. We know C goes with U because that's the order there. So C is in the same position as U. Then D goes with T. D goes with T. See, it's rotated. That's why we're color coding here. And E goes with S. All right, now, when you do the similarities, you have to match the order that you go. So, for example, this is red to blue. So it matches red to blue, which is the 16. So I'm going to do this. I'm going to go bottoms up. 8x minus 8 over 16. Then I have to find another set of sides that have nothing but numbers, and that would be the 63. That's my only other choice, and the 20. But watch the direction here. It's very important. The direction is yellow, red. So that doesn't match with the 20. You see that? The colors don't match. This goes blue, yellow. So you have to watch. Even though that looks like they match, you have to match those colors up, blue, yellow. So bottoms up. I'm going to do 63 over 18. You reduce before you cross multiply if at all possible. 9 goes into both of these, so I'm going to reduce it beforehand. 9 goes in there 7 times, 9 goes in there twice, cross multiply. 2 parentheses, 8x minus 8 equals 16 times 7. We're going to divide both sides by 2. And then you can take it from there. 8x minus 8 equals 56. Find the value of x if possible. So once again, we have to check for congruent angles. I have 87 and 19. So I'm going to add 87 and 19. I get 106. 180 minus 106, lo and behold, gets me 74. Aha! Which means this is 74, this is 19. So I know for a fact they are similar by angle. Now we have to match the sides up. Match the corners. This 24 is going from 19 to 87, so it matches with 1987. So 24 matches with 36. I'm going to go top bottom. And this is 7487. 7487 top to bottom. I'm going to have 14 over x squared plus 11. You cross multiply. I get 24 parentheses x squared plus 11. I'm not distributing. I'm going to see if I can't get rid of that 24 completely before I do anything else. Rather than distribute, it just makes it messier. So 24, 24. Let's see what we can do here. I know 6 goes into both of these. 6 goes in here 6 times. 6 goes in here 4 times. 2 goes in here twice, 2 goes in here 3 times, 2 goes in here 7 times. Aha! So I get x squared plus 11 equals 21. X squared plus 11 minus 21 equals 0. Now you're left factoring. X squared plus 11 minus 21 equals 0. You ask yourself, what numbers are multiples of 21 that might add to 11? And that's going to be 7. And you go ahead and you might need to use the quadratic equation for this. Or, hang tight, let me check. X squared plus, that's simply going to be, not plus, excuse me. And it's going to be minus 10 equals 0. X squared equals 10. And square root, so x equals the square root of 10. That's a legitimate answer. You can't go any farther than that. Circle the transformations that produce similar figures. Similar figures, same shape, different size. Same shape, different size. So that would be dilation only because it makes it larger or smaller. Translation gives you congruent. Rotation gives you congruent. Reflection gives you congruent. And the stretches do not give you either. So dilation is the only thing that gives you same shape, different size, which is the definition of similarity. Which of these can be proven similarity? Here. Let's check short to short. 18 is short. 42 is short. You ask yourself what goes into both. 3. 3 goes in here 6 times. 3 goes in there 13 times. Let's keep working ourselves around, medium to medium. 9 goes in here 964. 3 goes in here 9 times. 3 goes in there 3 does not go in there. It doesn't match. So this one is no, it's not similar. Come over here. We have parallel lines. So that at least gives us these angles here, which are corresponding, but you don't get anything else. So you're looking for angle. So no, they're not similar. Let's take a look here. We're going to add 68 and 35. Carry the 1. It's 103, so that means this must be 77, because 180 minus 103, 77, which means I have a pair of angles and another pair of angles, which means it's angle-angle similarity. So yes, it's similar. You're looking for angle-angle similarity, so we have a pair of angles and another pair of angles. Yes, that is similar. Here, they're not similar. We get a pair of congruent angles here. We have a pair of sides and a pair of congruent angles. That's all you know for sure. That doesn't give you similarity. Coming over here. Parallel lines, alternate interior angles. Yes, that's one pair, and vertical angles. So yes, those are similar by angle-angle similarity.